The James Webb Space Telescope has once again delivered images that have sent shockwaves through the scientific community. This time, its eye was turned toward Proxima Centauri b, more commonly known as Proxima b, the nearest known exoplanet, to Earth located just over 4 light-years away within the Alpha Centauri system. An unexpected discovery was made by the James Webb Telescope, City Lights in Space, positioned 7 trillion miles away from Earth. This remarkable finding has sparked curiosity about the possibility of extraterrestrial life. The telescope focused on Proxima Centauri b, the closest exoplanet to Earth, revealing unusual bright lights emanating from it. What could be the cause of these city-like lights on Proxima Centauri b? Could this indicate the presence of life beyond our planet? Join us as we delve into how the James Webb Space Telescope detected these extraordinary objects in space. For years, scientists and the public at large have waited and researched to catch a glimpse of life beyond our solar system. Any evidence that seems to support this space myth has been welcomed with open arms over the years. Recently, the scientific community received the shock of their lives when solid evidence of life forms existing in space was discovered by the James Webb Space Telescope. While scouting outer space and reporting vital information back to Earth, the James Webb Space Telescope observed strange city-like lights shining from the exoplanet, Proxima Centauri b. These lights were just as their name implies, lights resembling those that illuminate a distant city. The possibility of an alien city existing on the star has left scientists reeling in surprise. Every one of them is baffled, as it appears this could be the life they've all been anticipating. If this turns out to be true, as many believe it is, it means that intelligent life forms are organizing civilizations beyond what humans know in outer space, and we are only just discovering it. Peering into the city lights, which are located 7 trillion miles from Earth, NASA engineers cannot help but marvel at how long these lights have shone in space, awaiting humans to develop the necessary technology to detect them. David Kipping, an astronomer from Columbia University, describes Proxima b, where the city-like lights were found, as challenging. He noted this because the star system nearest to us has heating patterns that differ from other planets. Typical rocky planets are known to absorb sunlight and emit infrared radiation. However, Proxima b's infrared signature is quite different from that of its host star named Proxima Centauri. This makes for an incredible observation by the James Webb Space Telescope, JWST. And the telescope proved to be the right tool for the job. The JWST is capable of easily detecting infrared wavelengths. The distinct heat signature of Proxima b will play a significant role in uncovering the familiar secrets of its atmosphere. This will be achieved thanks to the advanced infrared imaging capabilities possessed by the JWST. Scientists plan to use the telescope to reveal the mysteries surrounding this planet's atmospheric components. They also aim to use the Webb telescope to assess the possibilities of life on this exoplanet. The James Webb Telescope's infrared sensitivity is poised to explore what happens on Proxima Centauri b's night side. Picking up the faintest rays of light in the cosmic darkness is usually a struggle for space telescopes, but not for the JWST, as it can detect even the tiniest rays of light from space. It is the perfect instrument to confirm whether the rumors of city lights on Proxima b's night side are true. Any artificial illumination in the cosmos can be sensed by the telescope as long as it falls within a frequency band that is 100 times narrower than the starlight. Proxima has an intriguing relationship between its stellar features and surface interactions. The day side of the exoplanet contains many solar panels that harness the radiant energy emitted by the star. Its spectral edge also reflects incoming light rays simultaneously. As Proxima b completes its orbit around its host star, Proxima Centauri, it experiences day and night periods, similar to those on Earth, with the daytime receiving intense solar heat and the night experiencing coolness. The planet is known to have temperature fluctuations determined by its composition. For example, if Proxima b lacks an atmosphere, the difference between its day and night periods would be vast. Without the moderating effect of atmospheric gases and oceans, the temperature of the day side would be extremely hot, like a black body, while the night side would drop into cold darkness. The degree of temperature variation is a critical issue for astronomers to resolve for a deeper understanding of Proxima b's atmospheric composition. With its unmatched infrared imaging capability, the JWST can accurately study the planet's thermal emissions to provide insightful data about its atmospheric properties. Interestingly, the orbit of the James Webb Telescope around Earth aligns with Proxima b's orbital period, enabling complete observations of its day and night periods within 11.2 Earth days. If Proxima b indeed has an atmosphere, the next step will be to assess its atmospheric chemistry to determine if it could support life. Some key indicators of potential habitability include the presence of gases like oxygen, water vapor, and methane. If these elements are found on the planet, it suggests it may support habitable conditions. It's a process of accurately determining. This requires scientists to meticulously capture and analyze light rays that pass through the planet's atmosphere. It's a challenging task to undertake, even though the JWST possesses remarkable capabilities for characterizing planetary atmospheres. It has a specific primary goal. The telescope is customized to analyze variations in water vapor, carbon dioxide, and methane concentrations. When it comes to identifying bonded oxygen, a crucial indicator of life, the JWST is limited in this area. Nevertheless, the telescope still has valid reasons to search for other elements, such as ozone, which provides an accurate measure of energy in the atmosphere. It's also worth noting that the James Webb Space Telescope does not have absolute capabilities and can only examine the closest habitable worlds to Earth, conducting thorough atmospheric investigations. Astronomers are now leaning toward ground-based observatories like the Extremely Large Telescope (ELT), which is scheduled to begin operating in 2028. The ELT is well positioned to gaze deeper into the atmospheric structure of distant exoplanets. It will produce data on these planets that will provide comprehensive and vivid insights into their level of habitability. NASA, scientists, and others are eagerly awaiting the deployment of future space telescopes like these. Until then, however, the James Webb Space Telescope remains a vital tool in our quest to uncover the mysteries of distant exoplanets. Despite its current limitations, the Webb telescope has the potential to provide deep insights that will revolutionize our understanding of exoplanetary exploration now and in the future. Scientists have a goal for future space telescopes to reduce the amount of bright light coming from a planet's host star so that astronomers can better see the light reflected from the planet itself. They plan to achieve this by using internal masks or large external satellites shaped like an umbrella. Similar to using your hand to block out the sun's rays to see an object more clearly. Reducing the intense brightness from the host star, future telescopes will be better equipped to observe faint reflections of light from distant exoplanets, allowing for precise analysis of their atmospheres and potential to support life. This comes with its own challenges. However, scientists will need to differentiate between gases generated by life and those produced by geological processes, such as volcanic activity. Astronomers are not giving up on understanding the characteristics of exoplanets, so they can better identify signs of life and distinguish them from false positives. The Webb telescope offers a preview of scientific advancements in exoplanet research, providing a glimpse into the remarkable discoveries yet to come. As we stretch our understanding and exploration of the cosmos further, we are better positioned to comprehend the intricate workings of the universe and our diverse roles within it. After examining countless planets in space, scientists have yet to discover any that definitively host life. Despite decades of searching for signs of life, the quest for extraterrestrial life on other planets continues. Are we alone in the universe? For millions of years, the narrative surrounding the James Webb Space Telescope has fueled speculation that aliens may be out there in the stars waiting for humans to discover them. To address this question, two American astronomers, Jill Tartor and Thomas Pearson, started a project in 1984 called the Search for Extraterrestrial Intelligence, SET Institute. This nonprofit initiative aims to sift through cosmic signals to detect radio signals from space. The focus on radio signals is due to their ability to travel long distances without being scattered or absorbed. Unlike other forms of radiation, this makes them more likely to be detected by the 42 radio telescopes that make up the Allen Telescope Array in the Cascade Mountains of California. Although the SETI Institute has diligently searched for signs of radio signals generated by intelligent life, no such signals have been detected in over 30 years. Jill Tartor remains optimistic, stating that they aim to use 21st century tools to accelerate the search. In her words, "I wish that you could empower Earthlings everywhere to become active participants in the ultimate search for cosmic company." Recent reports from NASA suggest that the James Webb Space Telescope observed city-like lights from a planet near Earth. The JWST is humanity's most advanced tool for unraveling the mysteries of the universe. Currently floating about 1 million miles from Earth, it sends precise details about the earliest periods of the universe. It is designed to capture previously elusive data about space, providing clarity on the formation of galaxies, planets, and stars. Astronomers have capitalized on the JWST's cutting-edge technology, including its stellar camera function and filters to identify and analyze the subtle hues surrounding celestial objects. Researchers comfortably use the telescope to gather data about the physical properties and chemical compositions of celestial bodies located far away in the cosmos. This is achieved by isolating specific wavelengths of light beyond mere observation. The Webb telescope constantly scans the atmospheres of exoplanets for faint traces of life, no matter how small. It has unmatched power to analyze the fabric of time and space, and has uncovered some of the most intriguing findings ever. One such discovery is the existence of more mass than previously believed in the universe, stashed away in several large galaxies, effectively casting doubt on the earliest design and proportions of the universe. Humanity has since set out to explore the farthest reaches of the cosmic plane, using the JWST as an integral tool for achieving this. Through the telescope, new data on isolated worlds will be documented, and more astrophysical data will be available to resolve the mysteries of these planets. 20 years ago, the cosmic realm outside our solar system was largely unexplored. Since then, astronomers have identified over 4,000 exoplanets orbiting distant stars, demonstrating the extent of human ingenuity. Still, NASA considers these discoveries just the tip of the celestial iceberg. Scientists believe there are trillions of exoplanets scattered throughout the cosmos that remain undiscovered, undeterred over the decades. Scientists continue to explore space in hopes of finding alien habitats in uncharted territories. They have had glimmers of hope during this quest. When Galileo's spacecraft traveled to Jupiter, a spectroscopic tool unknowingly revealed a unique spectral signature that lent credence to extraterrestrial flora. This was the first time scientists observed a biosignature indicating the presence of life in the cosmos. Biosignature, known as the vegetation red edge VRE, detects alien life by closely analyzing how it reflects light. With the help of the VRE, the James Webb Space Telescope is expected to unravel the mysteries of extraterrestrial environments by meticulously mapping the orbital parameters of potentially habitable planets within the habitable zones of their parent stars. Once detected, the VRE can provide essential evidence in the search for intelligent life beyond Earth, unlocking a new journey in unveiling the mysteries of the universe. When sunlight passes through a planet's atmospheric layers, the disintegrated light carrying specific wavelengths is absorbed by the atoms and molecules in those layers. As observation continues, A distinct spectral pattern, akin to unique fingerprints, is formed that can be deciphered through spectroscopy. Analysis. It's a common theory that when light from stars reaches a planet, the Webb telescope will be able to detect it as it enters the planet's atmosphere. This knowledge suggests that the James Webb Space Telescope JWST could be the missing link in unveiling the atmospheric composition of these planets. The atmospheres of planets the size of Earth are rich in oxygen, nitrogen, and carbon dioxide. Though these kinds of planets might be able to host life, the lack of unusual compounds could point to alternative forms of life and technological civilizations. Chlorofluorocarbons, CFCs, man-made compounds used for refrigeration and other industrial purposes, could help scientists prove beyond a reasonable doubt that an extraterrestrial civilization exists. If the JWST finds such artificial molecules in the atmosphere of exoplanets, it will provide undeniable proof of extraterrestrial activity beyond our solar system. This opens a new window for cosmic researchers to understand the atmospheric compositions of other worlds and the slight probability of alien civilizations beyond the Milky Way. Life away from Earth. It's characterized by many possibilities that transcend the limitations of earthly biology. While we often think of life as flourishing in temperate climates, the reality of life could be far more extreme and complex. For instance, extremophiles, an intriguing group of organisms mainly composed of bacteria, challenge all that we've come to know as a suitable habitat for life. In conditions we consider extremely severe, these resilient life forms effortlessly survive and flourish. Extremophiles can live in and adapt to even the most horrific environments. With temperatures up to 250 degrees Fahrenheit and pH levels below 3. Their existence is a prime illustration of how enduring living things can be when faced with the most difficult circumstances. Consequently, the vast dimensions and innumerable environments of the universe reveal that our search for extraterrestrial life must be extensive. Planets that resemble Earth and orbit stable stars similar to the Sun make for excellent research opportunities. However, we should also consider alternative scenarios for exploration, such as exoplanets orbiting red dwarf stars, which are numerous in the universe. Though these red dwarf stars are not as bright as our Sun and their temperatures are generally cooler, they offer unique opportunities to investigate the possibility of life in varied environments. The extended lifespan of red dwarf stars provides ample time for the slow, complex processes of life's evolution to unfold. The James Webb Space Telescope's discovery of a new planetary system, known as TRAPPIST-1, is a significant development. The best part is that the planets in this system may support life and resemble Earth. The TRAPPIST-1 planetary system consists of a dimly lit red dwarf star and 7 rocky planets, similar to Earth, orbiting it. Among these 3 planets have been discovered to be potentially habitable and are likely to have liquid water on their surfaces. Though smaller and cooler than Earth's Sun, the TRAPPIST-1 star emits a soft light similar to that received by Earth. Scientists analyze the light from the star, as it could help in the hunt for habitable conditions in the remarkable TRAPPIST-1 system by studying the entire planetary system. The JWST has deduced that the red dwarf star is likely 41 light-years away from Earth in the constellation Leo. Excited about this development, Ward Howard, a research lead author and NASA Sagan fellow at the University of Colorado, Boulder, stated, because of JWST, it is the first time in history we've been able to look for planets around other stars that have the sorts of secondary atmospheres you could find around Earth. He also said, if you want to understand exoplanets, it's really important to understand their stars. At a distance of 4.25 light-years from the Sun, Proxima Centauri stands out among the many stars scattered throughout the universe as a beacon of potential. It is frequently referred to as the star closest to Earth. Its faint glow is barely noticeable in the darkness of the night sky from Earth. This low luminosity means that any habitable planets orbiting the star must be approximately 20 times closer to it than Earth is to the Sun. If these conditions are not met, None of its planets can sustain habitable conditions like our planet. On August 24, 2016, astronomers made an exciting discovery. A planet with 1.3 times the mass of Earth residing within the habitable zone of Proxima Centauri. This region, often called the Goldilocks zone, offers a delicate balance of light, intensity. It's perfectly positioned to melt ice for water and potentially nurture the seeds of life. Proxima b is a paradoxical exoplanet orbiting its host star, Proxima Centauri. The planet, just 4.6 million miles from its small red star, faces several challenges that threaten its ability to sustain life. Being close to its host star, Proxima b is exposed to intense solar winds, which can erode its atmosphere. Despite these difficult circumstances, the exoplanet receives enough sunlight to maintain an Earth-like temperature where liquid water could form. Due to its close orbit, scientists have observed tidal locking, which causes one hemisphere to be subjected to constant, intense sunlight while the other remains in perpetual darkness. Similar to the Moon's relationship with Earth, receiving just 18% of the Sun's mass, Proxima Centauri emits far less light than expected, challenging conventional expectations. Despite the challenges posed by its close orbit and potential atmospheric loss to solar winds, Proxima b offers compelling possibilities. If it has an atmosphere capable of storing heat, liquid water could form on its surface. This alone could initiate a chain of habitable processes on the exoplanet. Gradually, life forms in the water could evolve, spreading to land and air. However, Proxima b receives only 65% of Earth's total solar energy, making its prospects for supporting life relatively low. The planet's possible tidal locking creates extreme temperature differences between its scorching daytime and freezing nighttime. These harsh conditions are exacerbated by its close proximity to Proxima Centauri, subjecting Proxima b to intense radiation, including ultraviolet rays and X-rays, which are detrimental to its long-term habitability for Earth-like life. Additionally, the planet is constantly bombarded by high-energy particles during solar flares. Without a significant magnetic field like Earth's, these bombardments could strip away its atmosphere, removing the conditions necessary for life to thrive. Realistic projections suggest that tidally locked planets like Proxima b are likely to experience rapid atmospheric collapse as volatile gases freeze out at night. On Earth, volcanic activity replenishes the atmosphere, but for this exoplanet, no such mechanisms are known to exist. The mysteries surrounding Proxima b extend beyond its surface conditions to its potential for hosting advanced alien civilizations. Given the extreme conditions observed, it would not be surprising to discover that extremophile-like aliens secretly inhabit Proxima b, building alien huts and cities. With the knowledge currently available to humans, there is little insight into Proxima b's volcanic activity or the strength of its magnetic field. Nevertheless, the tantalizing possibility of an atmosphere fuels speculation about the planet's potential for hosting life. The presence of an atmosphere could indicate the existence of seas, dramatically raising the prospect of life in humanity's quest to discover signs of extraterrestrial civilizations. This desire to find alien creatures living on Proxima b has intensified in recent years, with speculations that such creatures could have developed advanced technological solutions to overcome the planet's inhospitable atmosphere. One wild theory proposes that aliens deploy vast solar panels across the day side of Proxima b to harness the star's energy, warming the perpetually dark night side and transforming the bleak landscape into a habitable environment capable of supporting life. The discovery of Proxima b has triggered a heated race among astronomers to determine if it transits its star's face. As observed from Earth, such transits allow scientists to measure the planet's mass and size, calculate its density, confirm its rocky composition, and gain valuable insights into its materials. Additionally, starlight passing through its atmosphere during these transits provides clues about its composition and habitability. Regardless of the challenges involved in demystifying Proxima b, the search to unravel its mysteries remains a priority. As long as humans have an insatiable thirst for knowledge about what lies beyond our solar system, they will continue to pursue extraterrestrial life. Proxima Centauri's frequent flares add another layer of complexity when investigating habitable worlds like Proxima b. Nevertheless, the James Webb Space Telescope remains invaluable. Staying out of reach of these flares and capturing critical images and data from the cosmos for study on Earth. What do you think about the artificial city lights? It's detected 7 trillion miles from Earth on Proxima Centauri b. Let us know your opinion in the comments. Don't forget to like, share, and subscribe to the channel for more interesting video content.